Okay, let's try this. All right, class.
Yes.
Okay, thank you. Good job. Yes, I bribed everyone. Everyone's going to be part of today's lesson today. This is my third hour today because everyone asked me all the time. Because there's usually someone in my video that I yell at all the time, and they're like, who is that person? Okay, so today, hashtag what?
47.
47, today's date. 20. Okay. All right, so let's take a look at this. Now, if we're looking at something right here, for this notice and wonder, what do we tell? So if we're actually taking a temperature over time, what do we know about the temperature over time?
Temperature decreases over time.
Yeah, decreasing over time, right? So if I were to try and draw a line to this, it would look something like this. Right there. Okay, cooling down. Okay, so now it is a curve. It is a exponential function, but this one right here is going down. We've been doing a lot of growth that goes up. Now we're going to do a little bit going down. Okay. So let's see. For this one right here, because we're looking to see a bottle of soda water is left outside on a cold day, scatter plot shows the temperature in degrees Fahrenheit of the bottle hours after it was left outside. Here are two functions you can use to model the temperature over time. Both of these would be a way to model it. So, looking at this right here, can someone tell me, what do you think my starting time is? Or my starting temperature?
45.
Yeah, there we go. So my starting temperature is 45 degrees because that's what they have in common, right? Okay, so it would be starting, and then from there, it's just going down. So we should be starting at a certain thing, 45, and, okay, temperature in degrees Fahrenheit. So both of them would model this. So if you notice, which one do you think is actually closer to all these dots? Is it F or G?
G. No, F.
It's going to be F, right? So F is the top one, G is the bottom one, right? So you guys can see this a little bit better. Let's see. So I am going to... There we go. So it comes closer to this. Okay, so it's closer to most of the dots, isn't it? There we go. That's the way that we're actually doing this. This is my F of H is the one that I was going to use, right? Okay, so next one, 45. Okay, what do you think 45 was supposed to be?
7.
Okay, 45 in the expression. 45 is right here.
Maybe only 7.
Okay. So 45 has something to do with this, right? So we said that both of these are having that, right? Having that temperature. So we said that it was a starting temperature, but that's a good way to estimate it. But this one right here, because the way this problem is set up, it's going to 45, isn't it? Okay, think about this. If you leave something hot in a room, okay, what's going to happen to it?
Temperature goes down.
It's going to go down. What if you leave ice cream in a room?
It melts.
Okay, it melts because so temperature is going up. So now, what is it actually happening? What's it doing? It's going to something, isn't it? What do you think it's going to? Room temperature. Thank you. Room temperature. So the room temperature, or in my graph that I'm dealing with right here, it's actually referred to as the ambient temperature. So it's the ambient temperature in this case because it's the temperature outside or around wherever I'm at. Okay, that's all we're trying to get to. Okay, so I'm going to skip this last one. Right there. Okay. So, right here, consider function given by this. Okay, explain how equation defining A is related to the temperature data. Okay, so where's my A? So it's going to be my,
2/3.
okay, and this one right here, my A of H. Remember, H would be my time, right? Okay, so if H is going to be my time, I'll write that down so we don't forget that. So if H is time, what do you think A would be? The temperature, the ambient temperature, right? That's what I was trying to get to there. So the ambient temperature, so that's the temperature that I'm going to end with. So it's going to curve down to somewhere. So it's going to be some eventual curve to somewhere. Okay, so we're not going to model this one here. So we're just trying to figure out whatever my temperature is going to be after I'm done with plugging in values. Okay, so what happened to the graph? Your teacher will give you a card. No, I'm not. Okay, take turn describing transformation of the graph of your card. Partner, draw the drawing transformation of graph, partner's description. Okay, so I'm going to show you what we have, and then we're going to talk about what it's doing. So first thing I'm going to do is probably should be using my blue pen. So this is supposed to be the same graph, same shape, but I suck at drawing. What did I do to my graph right there? I moved it up, right? Okay. Did I move it up a certain amount?
Like 2.
So we move this one up 2. So whatever my function is, I take my point that we have right here, and I use that one, which this point, anyone recall the name of that point? There's a special name for that point right there.
Midsection.
No. Starts with a V.
Vector.
Not vector. Vector has to do with direction. And evil minions that steal the moon. Vertex.
Oh, yeah.
So vertex. Vertex is going to be this point right here, which is the bottom of the parabola, or in some cases, top of the parabola. So that's going to be the vertex. So we moved it up and down. Okay. So now this next one here, let's see if I could actually sketch this right.
Vector encoded.
Okay. There's my Harry Potter right there. All right, so what do you think I did now to this?
Moved it over.
Moved it over. Which way? Which way is it going?
Right.
To the right. Okay, how much do you think I moved it over?
3.
Not 3. It's good to just pick a point on your graph and see where that new point is. So I'm picking this point on the graph, right?
1.
So that would go to this one right here, right? And so it moved to the right. 1. Okay. So the key to everything that we're doing in here is we have a spot here, we have a spot somewhere, and we figure out whatever the movement is there. So up, down, left, right, all that good stuff. Okay? So we're not going to do all of these right here. We're not going to do all of these. Yes, it is the backside. We did 2 of them. Okay, we did 2 of them. But we're going to go down to 6 right here. Ah, wait, wrong one. There we go. Okay, so now on 6.
You flipped it or you could either rotate it.
Is that a reflection?
It is. It is a flip. It is a reflection. It could be a rotation, right? A flip is a reflection. Okay? But that's the geometry terms, but let's go with the algebra term. What do you think happened to it? Yeah? But how would we do it mathematically? Think about all my numbers here. All these numbers are,
Positive.
and now they are.
Negative.
Okay, so what do you think I did to the whole thing?
Subtract.
Close. Not subtract, we'll say it. Switch the sign, right? So, okay, another way of saying it is I'm taking the opposite or I am negating it. So, if this right here is x squared, that means that this one over here has to be negative x squared. Very good. So negative x squared. So all I'm going to do, so this one is going to be, I'm going to take this and I'm going to, what were the words that we used? We said we flipped it, rotated, reflect, and negate. So we're going through and just moving and actually saying what it's doing for all these right here. Does that make sense? Super easy, right? Okay, that's all we actually have to do for all of these. So the homework's going to look just like this, and we're going to have plenty of time to actually finish up the homework today in class. All right? Like, share, subscribe, hit that notification button, and